All right, here we go. So number 10, one more time. Take two. Number 10. Well, first off, how are you going to recognize that it's any kind of binomial instead of one of those normal CDF? Percent, no mean, no standard deviation. Yes, let me write that. Exactly. So notice, take note, there's no mean, no standard deviation, and there is a percent right there given. Yeah, that's the sign that it's some kind of binomial thing, huh? So, because they'll all be mixed up on the test. They're all mixed up in order, and so you'll need to read it and go, oh, there's no mean, no standard, and they're talking percent. It's a binomial. That's the mark. That's the kind of thing you want to do for yourself. You know, this is what I did for myself. As I said, this is what everybody does for themselves in the math science world. In fact, education studies have actually shown that. People that are successful in math and science and foreign language, for some reason it's all the same kind of thinking, they organize their thoughts in nice little boxes. That's what studies of how we think have shown. So you want to strive that. You want to strive for that for your own work. As you get ready for any math or science or foreign language test, you want to try to organize everything into nice little shells. So that's what I'm trying to do, trying to help you do right now with those notes. I'm saying look for certain markers, right? I'm saying, oh, when I see, compare problems with each other. And say, oh, this one doesn't say mean. This one down here will say mean. That's how I know the difference. That kind of organization. That's what you want to spend time doing. Not just solving problems, but stepping back and comparing so that when that exam hits your hand, you won't look at it and go, uh-oh, they all look alike. You want to. That's why I give you the practice exam so you can practice that for yourself ahead of time. So, no mean, no standard deviation. They give a percent, so we know it's a binomial. Okay, and then we just hone in on the words. What are the words we need to focus on? Exactly 4. Exactly 4. So, let me see if which case is, yeah, exactly 4 is binomial PDF, huh? Binomial PDF. Number of trials, probability 4. So I'm going to do binomial PDF, trials, probability, and I'm going to put the 4 right there. So it's going to become binomial PDF. What's the number of trials?
4. 9.
Yeah, the 9, huh? The 9 adult smartphone users. You're checking on 9 users, finding out if they do something or other. What's the probability?
0.46.
Yeah, the 0.46. That's it. Hit the buttons on your calculator. Somebody got that value? Got it?
0.259.
0.259. Thank you. 0.259. 2590. Okay. Good there? Shall we move on to number 11? That was an easy one, huh? They get harder than that. 11 was where we got stuck, right? Wasn't it 11? Whoops, that didn't help. How are we going to recognize this as another binomial kind of question? No mean, no standard deviation, percentage there. Same thing again, right? Again, there's no mean, no standard deviation. Okay, so then we look at the words at least 2. So let's think for a second. So if I said, I've got in my pocket at least 2 coins, what does that mean? Doesn't that mean I have 2 or 3 or 4, etc.?
And at least will be the opposite.
Yeah, so at least 2 means 2, 3, 4, etc. Remember, though, when we do, if you look over here, when we do the binomial CDF this time, huh? CDF, at least means we're going to do binomial CDF. Number of trials, probability, that's easy. And the number you put here has to mean that or less. That's all the calculator speaks. So whatever you put there, you're telling the calculator it's that or less. That's just all it can do. So you have to be the one to make it work. So come in here and go, okay, now they're telling me at least 2, which I know means 2, 3, 4, etc. So the opposite of that, what's the opposite of 2, 3, 4, etc.? 0, 1, and 2. Yeah. That's the opposite of 2, 3, 4. Oh, no, not the 2. Sorry, I messed up. Just 0 and 1, huh? Just 0 and 1. Yeah, the opposite of 2, 3, 4, etc. is 0 or 1. If somebody said, hey, do you have 2, 3, 4 or more coins in your pocket? And I said, no. That means I got 0 or 1. Huh? That's the opposite. And so what are you supposed to do? Trials, what's it called? Probability. And then here you're supposed to be number, how did I put it? number or less. Yeah, number less. Yeah. So what number is that or less? 0, 0, 1 is 1 or less, huh? Exactly. That's how you know what to put in the binom CDF. So we go binom CDF. Number of trials is what?
7.
Yeah, it looks like 7. Probability 40.47, and then 1 for which represents 1 or less. Now but the question is, how do you know whether we're going to do a 1 minus the answer or not? Well, you ask yourself, did we ever do the opposite? Is this the opposite? Right there, I said we did the opposite, huh? So then I take 1 minus the answer when I get it, because that's actually the opposite.
0.9153.
That is 0.9153? Yeah. We did it so many times the other day, huh? 0.91, well, wrong a lot of times.
So 1 minus.
Oh, is it 1 minus that? Or is that the final answer?
That's fine.
Yeah, so it's 1 minus 0.0847, is that what it is? 6 something else round, and then eventually comes 9153. Good, is that making sense? And then number 12, questions on that one? And then number 12, I think, will be super similar. Number 12, purchasing batteries, whatever. Blah, 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 blah. Does it ever give you a mean? Or a standard deviation? Never, huh? Again, same thing. Even though there's a ton of words there, I don't want you to get, stuck on, reading tons of words and waste all your time. There's no mean, no standard deviation, and there is a percent right there. So we know it's a binom, huh? Just by that. It's got to be a binom. All right. So if this is a binom problem, then where's the at most, at least, greater, less thing? Do you see any words up there? Yeah, good honing in. At most 2. So let's write that out. At most 2. Now what does that mean? At most, if I say I've got in my pocket at most 2 coins.
2, 1, 0.
Yeah, it means 0, 1, or 2, doesn't it? At most 2 could be less, huh? Most I've got is 2, could be less, yeah. So now remember how the function works, the binom thing. Binom CDF, let's go back to it. Where is it? Right there. So here's the at most case. At most, do binom CDF, trials probability, and again, the last part is always that or less, isn't it? So binom CDF, trials probability, number or less. So do I need to do the opposite, or can I just stick it in there? Yeah, it's 2 or less, isn't it? It's 2 or 2, 0, 1, 2 means 2 or less, doesn't it? So I never had to do opposite there on that one. When do you have to do opposite? Greater cases. Any case is greater because the binom, so at least or more than or anything where it's talking greater, because the binom CDF function can only take numbers there or less. It can't do greater. So if they ask you a greater question, at the end you got to do opposite, right? You got to do 1 minus the answer. Is that making sense? It's just the limitation of what your calculator can handle that makes us do these tricks. So binom CDF. Number trials?
47.
Yeah, looks like it, huh? 47 batteries. 47 batteries. What's the probability each time?
0.02.
Yeah, the 0.02. 2. No need for opposite. So I'll write no opposite. No 1 minus answer. So anyway, so we got an answer there?
9323.
9323.
Yeah.
Gonna have a couple people get that?
Yep.
Good deal. There it is. On that one. Is that good for 10, 11, 12? So put on your card whatever you need for those. So you should have that, the notes that I sent you. Any questions? Those good? Want to go forward to the other ones? All right. Good. Let's move forward. We've talked it today. Okay. Now, remember how the curve thing works, right? When they give us the curve, up here is the percentage and the normal CDF, and down here is the inverse norm, huh? Have that in your card. So the way I put it in the notes is I said, well, it's not there, is it? Let me go grab it. Here it is in the notes, 13 and 14. When they ask for a percent, you do the normal CDF. When they give you a percent already, instead of asking for a percent, that's when you do the inverse norm. You know, I couldn't draw a curve, so I just wrote those words. So here, I'll draw a curve on the notes. Percentage up here, and normal CDF. And down here, inverse norm when they ask you something on the bottom, huh? All right. So which one is this then? So problem 13, are they giving me a percent or asking me for a percent? Yeah, they're not giving me a percent anywhere, are they? So they're asking me for the area here, right? Aren't they? Yeah, find the area. So they're asking me for the area. So when they're asking you, wait, there. When they're asking you for this area, you're going to do normal CDF. When they ask for the percentage, which is the area, normal CDF. So I mean, the percentage is the area. Maybe I should have said the percent. Whenever they give you like area up here, that is percentage. Area is percentage. So I'm going to do normal CDF, left, right, mean, standard. So I'm going to do normal. Oops. Normal CDF. Left, right, mean. How would you know this is not a binomial question? We got a mean and a standard deviation, don't we? It's not a binom question. Yeah. All right. So here we go. Normal CDF. What's the left? What do we mean by left and right? Left and right of what?
The left would be
Yeah, that we mean the left and the right edges of the shading piece, don't we? The left and right of the chunk of shading. So what's the left edge? Minus 1.04. And what's the right edge?
999.
Yeah, 999. And what's the mean?
0.
Oh yeah, they told me, huh? Mean is 0, standard is 1. Boom, hit the buttons. Somebody got a total there. What you got, Val?
0.8581 or
8581?
0.510. Or yeah, go round up, right?
Point. So it's what is it? Point.
I got 0.8508.
Oh, 08?
Yeah.
Anybody else get that same thing? All right, sounds good. There we go. Is that good? And then question, ready to move on to 14? So I'll just leave 14 right there. So on 14, it says find the indicated z-score. So try 14, right? Maybe rather than me whip it out real quick. Try 14. Look at those notes if that helps, or think about what we're doing on 14. 14 is a little more tricky. Give you a second. Okay, so how do we know whether it's normal CDF or inverse norm? Yeah, I want the thing on the bottom, which is inverse norm. Or, yeah, what you guys said, this is the percentage or the decimal. Yeah, so I'll go back to the notes. Wait, where are they? Nope, not there. There, yeah. So it says, when they give the percentage already, they are, huh? This is the percentage. It's a decimal, but same thing, huh? Yeah, they're giving you the percentage or decimal already, so, and they're wanting you to find the thing on the bottom, so it's inverse norm. Yeah, so we do inverse norm, and when we do inverse norm, it's area to the left, mean standard. So, whoops. So it's area to the left, comma, mean standard deviation. So it's inverse norm. What is the area to the left? That would be this area, huh? So how do you find it? So yeah, we can go back to the notes. Note, the first entry for inverse norm is area to the left. So if the graph gives area to the right, which our graph does, huh? We need to calculate area to the left is equal to 1 minus area to the right. It's like rain, not rain. 80% chance of rain, 20% chance it won't rain, 1 minus. So yeah, so area to the left. it's gonna, and if you want, you know what you could do, guys? You don't even have to, these calculators are nice. You could just simply type in 1 minus 0.7673. You don't even have to like calculate it ahead of time. If you want, you can just literally stick 1 minus right there. It's smart enough, it can deal with that. Save a step. You don't have to. Right? Because that'll be area to the left will be 1 minus the area to the right, huh? Because they have to add up to 1 total, 100%, which is 1 decimal. And mean, 0, standard deviation, 1. I think that'll work just like that, won't it? Inverse norm. And I'm getting... Did you get 0.7299?
For, yeah, 7.7299.
Oh, negative. Oh, and it wants me to, how far is it? 2 places. Negative 0.73? That's that Z spot. I got confused at first. It's that spot on the bottom. It should be negative. The negative threw me off. But no, that's right. That's right. Because here's 0, and that little Z spot is left of 0. That's right. I kept thinking it was a percentage at first. And I thought, there's no negative percent. What's going on here? But that's a spot on the bottom, isn't it? So left of 0, yeah. Negative.
Mr. Harris,
0.73? Yeah.
I'm confused. Why do you have the -1 then?
Well, you don't have to. Remember, your calculator just does the right.
Okay.
So for...
We were wondering both things.
Oh yeah. Oh, the reason I do the 1 minus is because it when you do inverse norm, not for yours, but for every she has the best calculator in the room. Hers automatically, she can just tell it to go right, and it just does it. Do you have the same thing, Roger?
Yeah.
So those two have the. They paid more than $25 for their calculator.
So you,
Anyway, but for all the rest of us, this is area to the left when you do inverse norm. So you have to tell it area to the left. Well, they only gave me area to the right. So to give them this area, I have to take the whole curve, which is 1, the whole thing is 1, take away this. So it's 1 minus the right. Because that makes this whole thing here be area to the left. Is that good? So you got to do that if you don't have one of them fancy calculators. All right. On we go. Questions on that one? We good? Problem 15. Problem 15. I just gave you a note. Remember, percentile means percent to the left or percent below. I don't know if you remember that. We've talked about a million things in here. But percentile, like if you have a newborn baby and you take your baby to the doctor and they weigh it or they do the height and the weight, they say your baby's at the 30 percentile for height. That means 30% of all babies are lower height. That's what that means, right? It means percent below. So that baby would be a little less than average height, right? If the baby's at the 50 percentile, that's totally average. That means half of all babies are lower, half are higher. If your baby's weight is at the 70 percentile, that means your baby is more than average, right? 70% are below in weight, 30% higher. So it means percent below. So percentile is almost the same as percent, but it's got a little more, it's loaded with a little more meaning than just simply percent. It means percent to the left or percent below. Okay, so when they give me this question here and they say 13th percentile. So again, notice it's not just percentage, it's that and more. It's loaded with a little more meaning. It's 13% below or left. So which one of those graphs looks like it has 13% below it? D. Yeah, D for sure, huh? Just a little bit, 13% is just a small part below it, to the left of it, huh? Okay, and now they want me to figure something out. Well, again, it's going to be one of these, it's not a binom because we have a mean and a standard deviation right there, mean 0, standard deviation. So we know it's either normal CDF or inverse norm, right? It's got to be one of those two. You see how I'm distinguishing what formula to use when? It's not a binom. We have a mean and a standard. So it's either normal CDF or inverse norm. How do you know which one?
We already have the percent.
Yeah, we already have a percent, don't we? We already know bottom 13%. So they're telling me this is 0.13, aren't they? That's what they're telling me.
So we figure out the bottom.
So we're figuring out the bottom. And so that's inverse norm. Yeah. See that? Make sense out of that? So, by the notes again, it's when they give a percent already, 13%, huh? Inverse norm. Inverse norm. So they're giving me the percent already, or the decimal, same thing. They're giving me that already, so they want me to find the bottom number. So it's inverse norm. Inverse norm. And remember again, this is area to the left, comma, what? Mean and standard. Okay, so what is the area to the left? Is it just the point 13? Totally. Huh. It's just the point 13 straight, isn't it? That is the area to the left. Well, so we don't have to do a 1 minus here. Notice. So I could give you a simple rule. When do you have to do the 1 minus? When they give it to the right. Yeah, because again, it's one of these formulas, and we'll run into this again and again in the course, that our calculator does certain nice things, but it has limits to how it wants the data. And for this, and the binom CDF, it always wants left. That's pretty much always what they're going to do. They want left. So if you have right, you got to do 1 minus when you stick it in. We're going to have that again and again throughout the course. So you kind of just file that away in your long-term memory. That basically all these things we do in the calculator, they always just take it to the left. So if it's already left, like ours is, then great. Just put it in straight, no need to mess around. But if it's to the right, like the last problem, right? The last problem was, this area was 0.7673 on the right. Then we put in the 1 minus because the calculator only thinks left. That's all it can do. All right, so put that in. Mean is 0, standard deviation is 1, right? Yeah. Hit the buttons. Somebody got it?
Negative 1.12.
1.12. Anybody else getting the same thing? That looks right to me.
No. Negative 1.13.
1.3?
Yeah.
Oh, it just rounds a little different? Okay. Negative 1.13. That good? On that? Questions before we move on? All right. Assume that IQ scores. So right away we see that they're giving me a mean and a standard deviation. So it's not a binom, it's a normal CDF again, or a inverse norm. Okay, find the probability random selected greater than 125. A hint, draw a graph. So you don't really have to, but it might help. So I'll draw a little graph. So what are they saying? It's good when you draw the graph, just put the middle on there. What's the middle?
98.9.
Yeah, that's that right there, huh? The mean, the middle, 98.9. And where's our spot?
125.3.
Greater than 125. So 125.3, is that on the right side or the left side? Yeah, it's bigger, huh? 125.3 is bigger than 98? And greater, greater is to the right, huh? Greater. So, and find the probability. They want me to find the probability, which is percent, huh? Probability is always percent. So they want me to find the percent or the decimal or whatever of that. Okay, so am I going to do?
Normal CDF.
It's normal CDF, isn't it? Right? Because it's not whenever you want a percentage, that's the normal thing to do. So normal CDF, and that's left, right, mean, standard deviation, huh? So normal CDF. What's the left edge?
Negative 999.
1.25.
Yeah, it's the 1.2. That's the left edge, huh? So it's the left edge of the chunk of shading. We good so far? That's the 125.3. And what's the right edge of the chunk of shading? Yeah, it's the 999. Mean, they told me that somewhere. Yeah, 98.9. Standard deviation, 15.6. Now, the only thing I want to caution you, we're actually good. This is going to be perfect. But in a minute, we're going to go to the ones where you need to divide the standard deviation by the square root of n. Remember those? So how do you know when you need to do that? If there's a group, huh? If they said, 20 people, and so they give you a group number, then divide, then it's exactly the same, but you just divide the standard deviation by the square root of n, huh? That's the only. So these don't look exactly like this. The only difference is they'll say, what's the mean for a group of 20 or 25 or whatever, and you would just divide that by the square root of n. So yeah, is that good? Does that make sense? Somebody got a number there?
0453.
5, 3. 0.5. Okay. How do I know right away that can't be right?
No, it's 0.0453.
0.0.
Oh, okay. Gotcha. That sounds better. 0.0453? 0.04. Yeah, that looks reasonable. What if I had, let me help with that too. Is that good? A couple people getting that? That looks right to me. That good? All right. What if I did, by the way, let me just mention, what if you got 0.53, for example? How would you know that can't be the answer? Because it's easy to hit a wrong button, huh? How would you know that? How would you catch it?
That'd be 51%,
Yeah, how do you know that graph can't fit with that?
because the mean is right there in the middle at 50%.
Yeah. So this shading, is that more than half the graph? Yeah, no way, huh? So the answer can't be more than half, can it? You know what I mean? Because what we're answering the shading. That's what we're saying. We're saying the shading is 0.0, that's about 4%, 4.5%. Yeah, I just know it's something less than 50. Makes sense? So it's easy to, and I think that'll really help if you do the left-right thing wrong. You'll actually get the wrong, like if I did the left-right thing wrong, I might get 96%. And I'd look at that and go, that ain't 96%. And then I'd go, oh yeah, I'm doing the wrong 1 minus or whatever. So watch for that. Just kind of just kind of think about your answers and look at the shading and know if it's more or less than a half. Good so far? All right. A lot of words. Number 17. Okay, well, cutting through all those words. I mean, it says normal distribution right there. They're giving me a mean and a standard. So we know it's another one of these, either normal CDF or inverse norm. So I think it's always helpful to draw a little graph. So I'll try to draw a graph. And what are they saying? Let's start by putting the middle on the graph. What's the middle? Yeah, 22.9. So we'll put that right there.
1.1.
And there's the standard, yeah. And now, what are they talking about? If you read all these words, they say instead of using 0.05, blah, 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 for significantly high, use 0.01. So, long story short, they're saying let's use, see what this says here? Just that part right there. Well, I shouldn't do just that part right there. How about this part right here? X or greater. So that means here or greater is 0.01. And then this part says X or less is 0.01. So that means here or less is 0.01. That's what they're talking about, those two spots. Do you see how I figured that out? It's kind of confusing from those words. So they're saying the probability of some spot or greater is less than or equal to 1%. So that's going to be some spot really, really high. There or greater is less than 1% of the curve. That's what they're saying. And then here they're saying find some other spot X such that that spot or less, that spot or less is under 1%, 1% or under. So some little tiny part on the left and the right edges that are both 1%. That's what they're saying there. And they're basically saying, find that spot and find that spot for me. So, is it normal CDF or inverse norm? Yeah, it's inverse norm, huh? Do we all see? Because they're giving me the percentage, huh? Or the decimal, same thing. They're giving me that, so it's not normal. It's inverse. Whenever you want to find the bottom, that's the inverse, right? The inverse is always on the bottom. So yeah, it's going to be inverse norm. And what do we do for inverse norm? Area to, now be careful with this, area to the left, comma mean, comma standard. Right, that's how we always use inverse norm. Area to the left, so it's back on the notes here. Oh wait, is it? Yeah, there it is. 16, 17, 18. That's where we're at, right? Yeah. Notice they give a mean and a standard. When they ask for a percent, that was the other one. We're on, what number are we on? 17. We're on 17. So on 17, they give me percentages already. Right? They're giving me the 1% top and bottom. They're giving me the percentages. Then you do inverse norm, area left, mean standard. So, all right. So we're going to do this twice, two inverse norms. One to find the left edge, 1 to find that spot. So what are we going to put in to find that spot? That'll be inverse norm. What's the area to the, if you're finding the left spot, this spot here, what's the area to the left? 0.01. It's just straight 0.01, isn't it? 0.01, and then the mean, whatever it is, 22.9. Standard deviation, 1.1. Okay, somebody got a number there?
20.34.
It's got to be something. Oh, no, that could be. 20.34? Thank you. Anybody else get that same number? Okay, good. Sounds good. Got double verification. And then, and now, the more tricky one is to find the other one. So, inverse norm. Okay, now I want to find this spot now. Now, why is that one more tricky?
If you're the left.
Yeah, because the 1 minus. Because right here, remember when the inverse norm function, like so many functions we'll see in our calculator this semester, always wants left. All it can think is left. So we really have right is 0.1. So the calculator will say, don't tell me about right. I can't think that way. You just tell me how much to the left, and I'll give you an answer. That's basically how it works. So we want this spot, and say, I'll give you that spot, but you have to tell me the area to the left of that spot. That's just how I communicate. So how much area is to the left of that spot? 99%, huh? But you can just go 1 minus 0.01, or you can just put in 0.99. It'll work either way, right? Because there's 1% above it, so that means 99% of the area is below it. Like this is the top 1% for whatever it is we're doing here. Back to knee length. This is the NBA players. They have the top 1% back to knee length. Anyway, is that making sense? So you always have to do area to the left, which is 1 minus 0.01, or you could just make it 0.99. It'll work either way. 22.9, 1.1, and is it going to be 24 point something?
25.4.
Oh, 25?
25.5.
Oh, okay. 25.5?
Yeah.
Do you want 2 places?
One place.
Oh, 1. You're right, thanks. 25. This other one should have been 20.3, I guess, then. 25.5. So we found those 2 spots. And then they're, is that okay? Does that make sense on that when you do inverse norm? You always, the calculator can only communicate in area to the left. So to find this spot, you got to go 1 minus 0.01, or 99% to the left. But when we found the left spot, that was easy because we already had it in left. We were talking the same language as the calculator on this one, right? But the one over here, we have to translate into the calculator's language. And he wants left, always left. Okay, and so what that means is, that means if, what is back to knee length? So how far from if you sit down in a chair from your back to your knee, the average person has got 22.9 inches, is it inches? Yeah, inches from their back to their knee. And if you go down here to 20.3, the smallest 1% of all people have a back to knee length that's 20.3 inches or less. And the tallest 1% of all people have a back to knee length that's 25.5 inches or more. That's what that data is saying. So what? What does that mean? Well, then they say, suppose somebody has a 25.1 inches back to knee length. Is that significantly high? In other words, is it in the shaded zone, the top 1%? Did it make it to the top 1%, 25.1? Not quite, almost, huh? But not quite. Yeah, 25.1 would be just below this. It's not quite in the top 1%. It's not quite the NBA player or whatever. So it's right there, right there. What is it, 25.1, huh? Almost there, but not quite. So our answer is no. It is, yeah, is not significantly high. It is, yeah, inside, you're right, inside the range of values not considered significant. Yeah. We good? All right, on we get. It says, survey found women's heights normally distributed. Mean 62.5, is that the average women's height? Standard deviation that. Survey, men's heights, average, blah, blah, blah. Most, this is the characters at the amusement park thing. Okay, find the percentage of men meeting the height requirement. So they're asking me for a man percentage. So, what am I going to do? Let me draw a min curve down here. Okay, and what goes right in the middle?
68.6.
Yeah, right there. That's the mean or average height for men. 68.6. Okay, and they're saying, what are they saying?
56 and 64 are the.
Oh, thanks. Yeah, the minimum have a high minimum of 56, max is 64. Yeah, so they want me to go from those two numbers. So I want me to go here to here from 56 to 64 like that, and they want that percentage. Is that making sense? What I'm drawing on there? So that I put the curve, put the middle for the min, and they want to know what percentage of men are within the minimum maximum height requirement for those costumes. From 56 to 64, which are both below average, huh? Only shorter men are going to be able to do that. And they want to know what percentage. So is it normal CDF or inverse norm? Normal, yeah, because whenever we go up top, it's normal. So normal CDF, which is always left edge, right edge, mean, standard deviation, huh? You can probably do this in your sleep now. Normal CDF. So what's the left edge? Yeah, it's the left edge, and that's the right edge of the chunk of shading, huh? 56, 64. The mean for the min, 68.6, and the standard deviation for the min, there it is, 3.6. Hit the button. Somebody got it?
10.04.
0.1004. Yeah, and then they want me to change to percentage, so that moves the decimal 2 places exactly. 10.04%. Anybody else get the same answer? Yeah, so 10.04% of men, so not a lot, not a big portion of the population, fit in that category. Since most men do not meet the height requirement, right? Only 10% of the men meet that. It is likely that most of the characters are women, huh? So, and then part B, maybe we better do it. Part B, if the height requirements are changed to exclude only the tallest 50% of men and the shortest 5% of men, what are the new height requirements? Okay, so can you draw a curve that'll fit that? I'll give you a second on that. The middle is, what is the middle? It's still 68.6? Okay, and then what do they want from me on this one? They want
50%,
tallest 50%.
which is the mean already.
Yeah, that's,
68.6.
wait a minute, so they want to exclude the tallest 50 and the shortest, the shortest 5, let me start here. So there's the shortest 5%. Right there, and here's the tallest 50%. How's that so far? Does that make sense? So the tallest, so we want to exclude the tallest 50% and the shortest 5%. So we want to make costumes that will only eliminate the tallest half a min and the lowest 5%, fit everybody else in between. So they're asking me to do that. What heights should, what are the height ranges for the costumes? Like, what's the smallest costume, the biggest costume that'll fit from here to here? Get the idea? So, okay, what is that? Is that normal CDF or inverse norm? Yeah, because they want me to find this number here, basically, huh? Because these are heights down here, aren't they? And it's always percentages up above. That'll always be how the normal curve works. We'll be doing the normal curve for the next 9 weeks. This is halfway week. We're at week 9 now. We have 9 more weeks to go. It'll be normal curve all the way, basically. And you can just know normal curve is always percentages up above and then something else down below, either heights or weights or lengths from back to knee or whatever you're doing, Always percentage up above, though. Always percentage. So down below, this is heights. So they want to know what are the heights, inches for the outfits. So yeah, it's inverse norm. So I want to find inverse norm. Inverse norm, which always means area to the left, comma mean, comma standard deviation. You know it quite well, huh? So if I want to find this spot, inverse norm, what's the area to the left of this spot?
0.05.
Yeah, it's right there, 0.05. I don't need to do 1 minus or anything, huh? The area to the left of that spot's 0.05. We good there? And the mean is whatever they said, 68.6. Standard deviation, 3.6. Hit the buttons. What'd you guys get?
62.7.
62.7. So 62.7 is the lowest height for the costume, and the 68.6 is the highest to fit what they said. Is that good? Questions on that? All right, I'll move on. The overhead reach distance, adult females are normally distributed with a mean of that and standard of that. Find the probability that an individual distance is greater than 215.9. Okay, and then, all right, so let's do, let's just jump down to part, well, okay, let's do part A. We'll do part A. So part A, find the probability that an individual distance is greater than 215.9. So, sounds like another one of the same thing. So let's put a curve. And what's the middle? The mean is 202.5. And then it says, find the probability that greater than 215. So that's 215 is a little bit to the right, huh? 215.90. Greater is to the right. And they want the percentage. They want the probability. Good enough. So is that normal CDF or inverse norm? Normal, because I want that percentage. So normal CDF. It's always left edge, right edge, mean, standard deviation. So then that'll be normal CDF. Left, what's the left edge?
215.9.
Yeah, it's the left edge of the chunk of shading. This is the left edge, huh? 215.90. What's the right edge?
9.
Yeah, it goes forever right, so that'd be 999. That's the right edge. 999. The mean is the 202.5. The standard deviation, 7.8. There it is. Hit the button. Somebody got an answer on that one?
0.0429.
0.0429. Anybody else get that same thing? Good deal. All right. Part B. Find the probability that the mean for 20 selected distances is greater than 201.20. What's different here? Now there's a group, huh? Exactly. So what do we do when there's a... See, part A was individual, whereas, individual. Just divide the standard deviation by square root of n, huh? By square root of 20. That's the only difference. So if you got that down, I'll go to a fresh screen and do part B. Yeah, that's what they're testing. So you want to watch that. They'll be all mixed up on the exam. Just watch if it's a group. Same thing as usual, normal CDF. Just divide that standard deviation by square root of n. So let's do that. So I'll draw a little curve here again. And the middle, what was it? The mean is 202.5. And then they're saying greater, part B says greater than 201.2. So 201, that'd be over here a little bit, huh? 201.20. So greater. So we're expecting an answer. You tell me, are we expecting an answer more or less than half? More, because that's more than half shaded, huh? So it's good just to, it's easy to hit a wrong button or forget to do a 1 minus or something. It's just good to know, okay, I should get an answer more than 0.5. Should not. Right? Because the mean is 202.5, and they're saying greater than 201. 201 is left of that, so greater is more than half the curve. So it should be an answer more than 0.5. Okay, we want a percentage, so that's always normal CDF. So I'll do it up here. So normal CDF, left edge, right edge, mean, and standard deviation divided by the square root of n, huh? So that's normal CDF. Left edge, what's the left edge?
201.2.
This right here, this is the left edge. 201.20. What's the right edge? 999, because it goes forever, right? Mean is 202.5. And then finally, standard deviation is 7.8. 7.8 divided by the square root of 20 people. There it is. So that's the only difference, right? Just standard deviation divided by the square root of 20. And what do we got?
Is it 0.7719?
Point. Anybody else getting that?
20.
What's that?
20.
20?
Yeah, 7720.
Oh, it rounds, okay. 7720 sounds like that's the number. More than 50%, like we expected. And they say, choose the correct answer. It's normal because the original population has normal. Oh, why is it normal? Yeah, the original population is normal, right? The overhead reach distances are normally distributed. Remember there's limits on whether you can assume something is normally distributed. There's two ways. I don't know if you remember that. If the original individual heights or reaches or whatever are bell-shaped, then you can do any groups you want. They'll all be bell-shaped too. But we learned also, remember that little experiment we did with our phones and stuff, that even if the original data is not normally distributed, if you take groups bigger than 30, you'll make it bell-curved. Remember that? That's what they're questioning right now. So they're saying, hey, we only took groups of size 20. That's not bigger than 30. So why can we use a bell curve, which we are using whenever we do normal CDF, we're assuming a bell curve. Why is that okay? Well, it can be used because the original was already normal. Of course the groups are normal. The original individuals were normal on this one. So we don't even need to worry about the group size. Everything's normal. Everything's bell-shaped when the individuals originally were bell-shaped. Good on that? Questions? I'm kidding. But so this is probably a little bigger than I'm going to give you on the test. But you have to put those all in L1 on your calculator. Remember that? And then you gotta graph it. Is it normally distributed? Remember how to do that? What do you do on your calculator? I'm honestly kind of drawing a blank because, like I said, I'm learning this with you. Is it stat plot, right? Isn't it stat plot? So you got to, first off, you put it all in L1. So step one, tell me if I'm forgetting something. Data into L1. You do stat. Let me just write it better. So you hit the stat button.
You hit second stat.
Right, sure. Second stat and edit and L1, put the data into L1, right? And then on step 2, don't you hit stat plot? I mean second stat plot, but stat plot, right? And then there's something you have to do. Oh, you got to turn on the stat. If it's not already on, yours probably is on.
Turn on which one you want. You want the,
yeah, which one you want.
You want the dot.
The third one or the sixth one. Remember we did those two, whatever that other thing's called.
L1 is in there. You do a zero
Yeah.
line.
Stat plot. Choose the third. That's the bell curve, right?
Right.
Or the sixth. What's that called? Quart
Line.
I forget too. Yeah, that quartile line thing.
Yeah.
That line, remember that? Or the sixth one, which is
Line.
which is that thing.
Right.
So yeah, which is the quantile plot. Remember that one's supposed to come out a straight line. Remember the data are supposed to be in a straight line, like?
Straight line without a pattern.
Without a pattern, well said. Without a pattern. Oh, and then the bell. So basically you just put that data in L1, choose one of those graphs. If it looks like a bell, great, it's a bell. Or if you do the quantile plot and it's all lined up without a pattern, then it's a bell. Those are the two different ways we detected if data was really bell curved. Remember that? All right, grab me after you want to do more of that. And then, all right, yeah. So now they're basically saying, hey, there's some data too. So one of them, just one, not two, just one of them will be this enter the data stuff. So can you type all that in maybe 10 minutes and do a quantile plot, type all that into L1, quantile plot, same kind of thing. See which one of those it looks like. I don't know which one it looks like. Whatever your calculator says. It's going to be one of those pictures. We good there?